Okay, so my name's Kennedy. I work at EcoSuperior and I'm also a postdoc at Lakehead University. And yeah, today I'm going to be talking about understanding microfiber pollution in our home laundry. And I wanted to thank Abby and Leah for inviting me to give this webinar to you all. I had given it locally in Thunder Bay, and then Abby approached me, saying she was interested in learning more about the topic, but wasn't able to come all the way to Thunder Bay to see to see my workshop. So she invited me to give it online, which is such a great idea because now more people are able to attend both from Thunder Bay and elsewhere. So this is a really great idea and a great turnout from people too. So thank you all for attending. Okay, so before I start talking about the kind of research and all the background and stuff, I'll just give you a little bit of information about myself. So I was born and raised in Thunder Bay, and I left for about 8 years to do my undergraduate at the University of Guelph and my grad studies at the University of Toronto. When I was in Toronto, I did my PhD research on the sources, fate, and effects of microplastics in freshwater ecosystems. And now I'm a postdoctoral fellow at Lakehead, and I'm doing research on the pathways of pollution into Lake Superior through urban stormwater and wastewater. I always like to say that I do more than just think about plastic and where plastic is going in the environment. I have lots of hobbies. I like to fish. You can see a picture of me and my dog ice fishing here, hiking, camping, gardening, etc. And I'm really looking forward to the end of this eternal winter that we're in right now. Hopefully it'll wrap itself up soon and we can get on to spring. And my dog, she's in the picture with me. Her name's Rue, and she comes up later in the presentation. So keep an eye out for that. Okay. So what are microplastics? So I always like to start my presentations just talking about what microplastics are. There is a specific definition of microplastics, which is that they're smaller than 5 millimeters in size. And 5 millimeters is about the size of half of your pinky fingernail. So they're quite small and they can go all the way down to what's called the micron range. So if you look at a strand of your hair, that's about 100 microns in diameter. So microplastics can get down to that size and even smaller into the nanoplastic range. Some microplastics are intentionally added to products, such as microbeads that are found in abrasive cleaning products. They used to also be found in some cosmetic products, but quite a few years ago now, Canada banned them in cosmetics. So that was a really good idea because it otherwise they would have washed right down the drain after we are done scrubbing our face or whatever. But you still can find them in some abrasive cleaning products. So it's always good to use common sense. So if something says, it has abrasive, uh, or if something it feels gritty and it has abrasion in it, or if it says it has scrubbing bubbles, sometimes that can be code for plastic. So always check the ingredient label. And if you see something that says polyethylene or something like that, then you know that that's plastic. Other types of microplastics are produced unintentionally when larger plastic products break down over time. So, for example, the rubber particles that come from your tires, when you drive your car across a road, the tire scrapes on the ground and little pieces fleck off, and those are called, those are rubber tire wear particles, and that can get into the environment as well. Microfibers are a type of unintentionally produced microplastics from tiny threads that shed off our textiles. So that could be like clothing, towels, bed sheets, etc. Microplastics are everywhere on Earth. They've been found in more than 1,300 animal species, in the water we drink, the air we breathe, and in the food that we eat. Microplastics have been found all over in our bodies as well, in our lungs, livers, kidneys, blood, and reproductive organs. They can even cross the intestinal barrier into our brains and hearts. And while some microplastics are eliminated, many persist in our bodies. In the environment, pieces of plastic will never biodegrade. They just break down into smaller and smaller pieces, and that's called microplastics and nanoplastics. And that's one reason why it's so important that we stop the flow of microplastics into the environment because once they get in there, they're really, really hard to get out. So textiles are a major source of microplastic pollution. 60% of all of our clothes are now made of plastic. So, for example, when you see polyester, elastane, nylon, just to name a few, those are all different words for plastic, basically. Clothes that are made out of synthetic materials release plastic microfibers. Natural materials like cotton, silk, wool, etc., those also can release microfibers. And they're considered semi-synthetic because they have added chemical additives and dyes. So those chemical additives give them different qualities like water repellency, or sometimes outdoors clothes can be treated with different chemicals to repel bugs. All of those added chemicals change the nature of the plastic or the cotton and cause it to not break down as easily in the environment, especially for cotton. Textiles shed microfibers during manufacturing, daily wear, washing, and disposal. And domestic laundry is responsible for 35% of the primary microplastics in the oceans, with trillions of microfibers being released into the environment every year. So the current system for producing, distributing, and using clothing operates in a linear way from production to disposal. So we call this a linear economy, or the take, make, waste model. Large amounts of non-renewable resources are extracted to produce clothing that are only used for a short period of time, after which the materials are lost to landfill or incineration. Across the industry, only 13% of the total material input is in some way recycled after use. And most of this recycling is considered downcycling because the material loses value as it's made into different products like housing insulation, wet wipes, and mattress stuffing. So clothing is massively underutilized worldwide. The average number of times a garment has been worn before it gets disposed of has decreased by 40% in the past 20 years. More than half of fast fashion that is produced is used in under a year, disposed of in under a year. So this linear system puts pressure on resources, it pollutes and degrades the natural environment, and creates significant negative societal impacts at local, regional, and global scales. The current trajectory of the clothing industry will only lead to increased negative impacts, more CO2 emissions, more environmental destruction, and more waste. But there is hope. In recent years, brands and retailers have started to address specific environmental challenges in their supply chains, both individually and through industry-wide initiatives. However, most of these efforts are focused on reducing the impact of the current linear system, for example, using more efficient techniques or reducing the impact of materials. But a new textiles economy based on the principles of a circular economy would lead to much better societal and environmental outcomes. So this model that I'm showing here was developed by the Ellen MacArthur Foundation in 2017. Others exist, but this one I found to be the most clear, so that's why I'm showing it to you today. In this new economy, clothes, fabric, and fibers would be kept at their highest value during use and re-enter the economy after use, never ending up as waste. Transforming the textiles industry into a circular economy would require system-level changes that couldn't happen overnight and would require collaboration at multiple levels of the industry. The four major areas that this model, the Ellen MacArthur model, highlights are, first of all, and most importantly, phasing out substances of concern and microfiber release, and that's what we're going to talk about more today. But also transforming the way clothes are designed, sold, and used to increase the number of times clothing is worn, especially designing clothing of higher quality and increasing access to them by changing the business models, like investing more in clothing rentals. The third step would be radically improving recycling to allow the industry to capture the value of materials in clothes that can no longer be used. Currently, the industry is losing the amount of clothing that's worth almost 100 billion US dollars every year by material that goes to landfill or gets incinerated. And fourth, make effective use of resources, move to using more renewable resources, and transition to a more efficient production process that generates less waste. Okay, so the first and most crucial step towards a circular economy that we were just looking at is phasing out substances of concern to create a safe material cycle. Currently, many of the chemicals used to make clothing and other textiles have many advantages, including stain repellents and different colors. But these chemicals also raise concern due to their potential adverse effects. Some of these chemicals have been found to be carcinogenic or hormone disruptive and are classified as bioaccumulative or persistent in the environment. And secondly, we would also need to drastically reduce plastic microfiber release. So this would include two key actions, which are to develop new materials and production processes to design out microfiber shedding. So that's fundamentally changing the materials that we're using so that they release less microfibers. And then also increasing the effectiveness and scale of technologies that capture the microfibers that are unavoidably released. So if we have to release microfibers, at least we can capture them using new technologies. And that's kind of what we're going to talk the most about today. But at this point, you might be wondering, why are we so worried about the microfibers in our laundry? Because all of the water that leaves our household just goes to the wastewater treatment plant, and surely they take care of the microfibers. Well, wastewater treatment plants do play a very critical role in the fate of microfibers, but even the most advanced treatment systems can only capture 90% of fibers at best. Here in Thunder Bay, our wastewater from our houses goes to the water pollution control plant, where it undergoes primary and secondary processing before the final effluent is released into the Kaministiquia River. Because it is a secondary processing plant, we estimate that it is about 80% effective at removing microplastics. So if 700,000 microfibers can be released during every single load of laundry in every household in Thunder Bay, 80% efficiency is good, but it doesn't capture all of it. And there is a significant portion that likely gets released into the environment, although we haven't measured it in Thunder Bay specifically, but it has been measured elsewhere. So we currently don't know how many microfibers are released in Thunder Bay, but that is work that we are working towards. And some of the research that I'm going to talk about today is helping to address this question. So even when microfibers are removed from the effluent, they still might be able to find their way into the environment. So we talked about, I don't know if you can see my cursor, but we talked about this side. So that's released to surface water outlet. But during processing, at the wastewater treatment plant, the influent, so what comes into the water treatment plant, undergoes a settling process where all the organics settle out to the bottom of the tank, and then it gets processed in certain ways, and then it gets transported to different places. So in some places, that transportation brings it to a landfill where it just gets disposed of. But in other places, this biosolid is actually transformed into fertilizer, and it's applied to the land. So any microplastics that can get entrained in this biological material end up being transported and put back on the land, even though they were kind of captured at one point in time. So sewage biosolids have been a soil amendment that has been used in Canada for at least 30 years. In Ontario, we use it to restore vegetative cover of disturbed sites like mines, but more often it's used in agriculture. And when it's used in agriculture, it's mostly used for grow crops for livestock or fuel production, not necessarily for fruits and vegetables. And even though it's processed and treated and is highly regulated, this material is not considered an organic fertilizer. So if you yeah, if you get your veggies from an organic farm, you wouldn't have to worry about this. So the process of turning biosolids into fertilizer is highly regulated and it's managed under the Ontario Nutrient Management Act or the Federal Fertilizer Act. And those regulations, those acts have regulations on how far from a water source you can put the biosolids, the nutrient quality, and pathogens and heavy metals. But there's no regulations for microplastics as of yet. In Thunder Bay, we currently send, I think I said this, we currently send our biosolids to the landfill here, so it's not used as a soil amendment. And from what I could tell, doing a little bit of research, in Sault Ste. Marie, they also send their sewage sludge to the landfill, but in Sudbury, they do land application. So they use a process called Enviro to create the fertilizer. And the fertilizer that they create is approved by the Canadian Food Inspection Agency because it meets their guaranteed minimum standard that has thresholds for contaminants of concerns like metals, dioxins and furans, and indicator organisms like E. coli. But again, they do not have any regulations in place for microplastics. Okay, so why does clothing release microfibers in the first place? So microfibers are released by normal wear and tear during wear and use of textiles. So that can be just like when you're walking around, if your legs are swishing together, that abrasion can lead to microplastics being released into the environment. But more often, the case is that in the washing machine, the fabric undergoes mechanical and chemical stress. So, mechanical from the tumbling process, and chemical from any detergents that you add to it, that causes microfibers from the yarn to break apart from the textile. So, the release of microplastics is strongly related to the fabric yarn structure, quality, and age of the garment and the manufacturing process. So, I'm going to talk a little bit more about that. When we talk about how to reduce microfibers from being released, there's many things that we can do. First of all, and the most obvious one is to wash your clothing less, because if there's average of 700,000 microfibers released from a single load of laundry. If you simply cut it back from doing your laundry a little bit, that will help to not only increase the lifespan of your clothing, but also save water and release less microfibers. You can also avoid buying new clothing because new garments have been shown to release up to 8 times more fibers than older garments. You can wash full loads because that way the fabric doesn't get as abraded by the machine itself because it's more protected by the other clothes. And you can also change your settings. So using cold water and the delicate cycle, both of those have been shown to reduce microfiber release. If possible, you could use a front loader because those have been shown to reduce microfibers. However, I know that's not exactly the easiest thing to just go and swap out. So sometimes we have to do what we have to do. But then finally, we can pay attention to the material construction, material type, and quality of our clothing and avoiding fast fashion. So natural fiber clothing like cotton, wool, silk, linen, those materials, although they do release microfibers, they're typically cellulosic is what we call, so they're organic in material. And especially if they're undyed, those will break down over time. If the clothing is dyed, it is considered semi-synthetic, so it won't break down in the environment. But it is still better than synthetic, which is purely plastic and will last in the environment forever. Clothes with a tighter weave also release less fibers. So if you can see in the photo here, this figure N, you can see that the weave is really tight on the clothing compared to figure E, where the weave is much looser. So some studies have shown that clothes with a tighter weave release less microplastics than clothes with a loose weave. And then of course, if you have like fuzzy clothes, like fleece, for example, is a really it releases a lot of microfibers. So that's avoiding like fuzzy or yeah, material that's like fuzzy reduces how much microfibers will be released. Okay. So there is another way to reduce how much microfibers you release, which is called microfiber capture technologies. And there's different types of them. I'm showing you a few here. So on the top, you have a Cora ball. It's basically a little plastic ball that you put in your washing machine with your clothes, and it tumbles around and captures any fibers that get released from the clothing. Um, there's also this mesh bag called a Guppy Friend. It's quite a big bag, and you put all of your laundry inside of it before you put it in the wash, and you wash it in the bag. So the idea is that your clothes won't get as abraded from the mechanical stress of the laundry machine, and also it will capture all of the fibers that get released by your clothing in the bag, so you can like scoop it out after and throw it in the garbage. And then finally, the lint lever is an aftermarket washing machine filter that you attach to the effluent hose of your washing machine, and then you put the other hose into the municipal drain. And all the water that comes out of your washing machine gets filtered through the stainless steel filter, and then the clean water goes to the wastewater treatment plant. And so a colleague of mine at the University of Toronto did a study looking at the effectiveness of these different microfiber capture technologies. You can see the Cora ball here and the lint lever on the right. She found that the Cora ball was about 26% effective at trapping microfibers from the washing machine effluent, and the lint lever was around 90% effective. So the lint lever is, if you are interested in reducing your microfiber release, a filter like the lint lever is a really good way to go about doing that. And there are other brands of washing machine filters. I've chosen the lint lever for my project because it's Canadian made. It has a stainless steel filter that doesn't need to be replaced as often. Other filters, they have paper filters, and so you actually have to throw the filter itself away whenever you clean it and get a new filter. So with the lint lever, you just have one stainless steel filter and you don't have to replace it unless it like breaks, but that hasn't happened yet. Okay, so I'm going to talk about EcoSuperior's microfiber diversion project. So for this project, we are trying to address the issue of microfibers in our wastewater. And so we've partnered with the Métis Nation of Ontario and Lakehead University to distribute washing machine filters, which were the lint levers, to households in Thunder Bay. So we have participants that are citizen scientists, and they collect biweekly samples from their washing machine filters. They store them in their freezer, and then they bring them to EcoSuperior and give them to me, and then I bring them to Lakehead, and I count how many microplastics are in their samples. And I'm going to be using this information to estimate how many fibers are entering our municipal stormwater in Thunder Bay. So that could be per load of laundry, per household, and across the entire city. And currently we have 35 citizen scientists who have signed up and are currently collecting samples. Oh, there we go. So just a bit about the lint lever. As I was saying, you have the hose that comes from your washing machine, you connect it to the in port, and you have a hose that's included in the kit, and it goes to your out port, and then it connects to your municipal stormwater drain. So that's where your washing machine's already draining into. You just put this in between. And so it's very, very easy to install. And the kit comes with all of the stuff that you need to install it, except a drill. There's two ways that you can mount it. So you can either mount it up against a wall. So the kit comes with this metal bracket that you can install onto the wall, and then you install the filter onto it. Or the other option is to install it underneath a cabinet. The only thing that you have to pay attention to is that in order to get the filter cup, the blue cup, off of the stainless steel filter, you need to be able to pull it all the way down. So you need to have enough room between your filter and like whatever surface is below it so that you have enough room to take the filter cup off. for our citizen scientists who are collecting samples for us, this is the sample collection protocol that they're going through. So they're taking off the filter cup, and that's where I was talking about the you need enough space to go all the way down. And you can see on the filter here, that's my microfiber contribution. So it's pretty slimy and gooey, and it doesn't smell very nice. But once you get used to it, it's not too bad. You just have to be prepared, I think, in the first place. And then you pour the contents of the filter. So there'll be water in the blue cup. You pour that through the mesh filter bag that we also provide. And then you scrape all the goo into the bag. So there's just a quick video of me doing it. It's not too bad. You don't have to touch it because you can use the spoon to just scrape it all in. It's a bit of a tedious process. You just have to scrape as much as you can, as best as you can. And anyways, yeah. So then our citizen scientists collect the lint, so all that goo, and they put it in a bag for me. They squeeze out the water and then they put it in a Ziploc bag, and they take the weight of the sample. And then they store it in their freezer, and then they drop it off at EcoSuperior. And so that's basically what being a citizen scientist is for this project. Some feedback I've gotten so far from my participants. They have been surprised at how much laundry they do. We had one family who did 49 loads of laundry or something, and then they have three young kids, three young boys, and I had to message them because it was so elevated compared to the other people. I messaged them asking, if it was a typo, and they said no, they really did 49 loads of laundry, and they were shocked. And they were going to try and do less laundry going forward. So they said it was a good learning experience to see really how much laundry they're doing. Sometimes folks said that their clothes felt a little bit wetter than normal. And that was just a sign that the filter needed to be cleaned because there wasn't enough pressure going through the system to push the water through because the filter was almost clogged. So it's not there's not a risk to the machine or anything. It's just that the filter needed to be cleaned. As I mentioned, the odor, some people were very put off by the odor. It's it's a little bit farm-esque. If you've ever driven by a farm on a spring day, it smells a little bit like that. But the best way to avoid that is to do a load of laundry and then do your washing machine filter collection right after, because that's when it will be the freshest. And then the other main obstacle that we've faced with this project is that people who live in houses that have been built more recently or have been renovated more recently, their laundry tends to be built into like a cupboard or a tight space with walls on either side, which looks nicer for sure. But it means that they weren't able to access the hoses at the back of their washing machine to actually install the filter, and there wasn't enough space to mount the filter nearby. So that has been an issue and why some people haven't been able to participate. Yeah, but it's just kind of the nature of how the filter is set up. Okay. Oops. I'm gonna move into laboratory analysis. So this is my role at Lakehead, what I've been doing with the samples that the citizen scientists have been collecting. So basically, I have to get the filter from this state or the sample, sorry, from this state where it's just kind of a clump of fibers, but also pet hair, human hair, dirt, etc., into this kind of state where it's just the fibers that are from your clothing, and I can easily count how many fibers are being released. So that's what I'm going to show you how I get from A to B. So first I take a subsample because I can't count all the fibers in this massive sample. So I take a smaller sample of this, and I have to separate the fibers from the organics like the pet hair and dust and dirt. So for this, I had to do a proof of concept. So I wanted to see, does our method actually remove all organic material like pet hair and stuff? And so I used a chemical solution. So it's potassium hydroxide. And this is, if you remember what my dog looked like, this is her red hair. So this is Rue's hair that I'm digesting away to prove that I can actually remove all of the hair from my samples. And I know that it worked because this is what my final sample looked like. It's perfectly clear. So we got from this, which is clearly dog hair, to this like dog hair colored liquid. So we used a 10% potassium hydroxide solution for 24 hours. Oh, and this one has audio. It's kind of annoying. Okay, so I basically just did that same thing with my actual sample. And then I was able to sieve the sample through a sieve stack, so starting at 355 microns down to 38 microns. And this is what the sample looks like at the end. It's still pretty clumpy, but you can see some fibers already. But then I have to add another chemical to help break up those clumps. And eventually I can end up with a sample that looks like this, and I can actually go in and look at each individual particle and first of all count them, but also characterize them as being either cellulosic, so organic, or synthetic, so plastic. And then I'll take my samples to another machine called a ramen. Not like ramen, like the food. It's RAMAN, and it stands for something. I'm not sure what. Uh, and that machine, it's basically a laser that you point at the particle, and it will tell you what plastic type it is. So it'll actually tell you, is this polyester or is this some other type of plastic? So that will be the next step after I do the quantification. And then finally, I'm going to use that information. So by counting a known quantity, a known mass of my sample, I'll be able to extrapolate and figure out what all the different samples, all the different weights of samples, how many microplastics are in them. So that will tell me the number of microfibers per load of laundry or per household, and then across the entire city. And that is essentially the project, and that's where I'm at in the project. So hopefully by the next webinar, I'll have some answers for you to tell you how much microfibers we're releasing into Lake Superior or into the water pollution control plant, and then eventually into Lake Superior. And I'm happy to take any questions that anyone might have.